Friends, friends, today I'm going to discuss about buck boost converter. So this is a combination of a boost and a buck converter. What is a boost converter? A boost converter, we say that a boost converter takes a low input voltage to a high output voltage, and a buck converter takes a high input voltage to a low output voltage. So now this buck boost is a combination of two. It can act as boost converter, increasing the voltage, or it can also act as buck converter, reducing the voltage. How does this work? The same principle is being applied here, that this switch is being controlled by a PWM signal, as we discussed earlier. This signal is going to switch on and off. This switch here can be a transistor or a MOSFET. Okay. Then this signal here, as we discussed, this is the time is off, this time is on, off, on, off. So the input voltage will be connected at this point here. Then we'll get the output at this point. How does this one work? So it's still working the principle of a DC to DC conversion. So it is a DC converter, DC voltage which will be connected here, and we will still achieve a DC voltage at the output. But comparing the levels, the level will be different. It can be the high or low, because this one is a combination of both. Now, how does this type of switched mode power supply work? This is how it works, guys. This will be turned on. Okay, the current is already connected here to the collector of this transistor. So now the control circuit is on. I'll turn this transistor on. So at this point, the current will just pass through from the collector to the emitter. Okay, then reaching here, it will tend to go. It will find this diode is reversed bias, so it will block. So it will come. It will start coming here toward this inductor. Okay, when it comes toward this inductor will start storing energy in form of magnetic field. So no power will be got. So no power will be gotten at the output when this switch turns on. The power will only be flowing through this inductor. So the inductor will start storing charges. Now, at this point, someone might ask me, will it short? No, it will not. At this point here, it will not short. Okay? This inductor will not short because that's the way it's connected to the ground. Now, how does it going to get to work? So it starts storing energy in the form of magnetic field. Immediately, it switches off. This switch turns off. When this switch turns off, obviously, there is no current flowing here. So this inductor stores electrical energy in the form of magnetic field. So the energy stored here will now be released. When it's released, it will be released. It will turn to go this way. It will get blocked. This way, it will get blocked. Then this released energy will go this way. You can see it goes. It reaches the capacitor. The capacitor will start charging, and it's powered the load. Then, for this energy to get discharged properly, it must pass through the load, and it will come again here. It will find this. Now the diode will be forward bias, and it will continue like that until it discharges. So again, when it turns on, the same principle repeats. That it will turn on again. It will start charging. And it turns off, it discharges. So like that, the cycle will continue until you switch off the power, the supply. Now the function of this capacitor plays to function to supply the load. When the switch turns off, and also to smoothen the output voltage. It acts as a filter. So the reason why here is written off, this is because this diode conducts when this switch is off, as turned off. So coming back here again, you will find this V out. This V out meaning that we are going to design a feedback circuit which is going to compare so that we can get a steady state, a proper regulated output voltage. So what will happen after all of this we have explained here has happened, the result is that the magnitude of the inverted output voltage can be greater or smaller or equal to the magnitude of the input voltage based on the duty cycle. For example, if you feed on 5 volt, you can get 12 volt. And when you feed 12 volt, you can get 5 volt at the output. So the voltage output is calculated as voltage input duty cycle over 1 minus the duty cycle. So guys, that is the brief of how this back boost power supply operates.